Here we go. Forces in horizontal motion. Our essential question starts with, how do we apply Newton's second law to analyze a situation? Our objectives are, we need to understand the nature of friction, including static and kinetic friction. We're going to apply Newton's second law to situations where objects move horizontally along the horizon. And that's it. Easy, right? So here we go. Friction is a force that opposes sliding. Remember, it does not oppose motion, it opposes sliding. Relative motion between touching surfaces. Coefficient of friction is a number that determines how rough a surface is. The coefficient of friction depends on what the surface is made of. The symbol is this mu right here. Looks like a little U, Greek letter mu, pronounced like the Pokemon. There are no units, it's simply a ratio, so the range will be from 0 to 1. 0 is a very low coefficient of friction, where 1 is a maximum coefficient of friction. That is an immovable object. Static friction is the friction that acts between surfaces that are not yet sliding against each other. Kinetic friction is the friction that acts between surfaces that are already sliding against each other. So when we're talking about sliding, we're talking about this motion, where this motion, if you press down harder, you're going to feel more of the resistance. A force that rules your life as much as gravity does. You didn't think about that, did you? Friction is a force that always opposes motion. Silly misconception. Mr. Wright says friction doesn't oppose motion. Sometimes friction causes motion. Instead, friction opposes sliding. Friction is a major part of life, so we need to learn how to deal with it. Friction opposes sliding between surfaces. Sometimes that means that friction opposes motion, and sometimes that means friction helps motion. When you push the brakes in a car, friction acts to slow your car down in order to prevent the tires from sliding on the roadway. When you push the gas pedal in a car, friction acts to speed up your car in order to prevent the tires from peeling out on the roadway. The way that tires work are these tiny little points come in contact with the road, one point at a time. So it's not sliding. Instead, you have friction pushing the tires, causing this rotation or generating a torque to roll the tires. So when you press the gas, that is allowing friction to speed up the car. We learn more about torque and as it relates to things going in a circle later on through the year. When friction helps motion, we call it traction, but it is still the same interaction as friction. There's two types of friction, depending on whether the object is already sliding on the surface. Static friction acts when the object is not yet sliding on the surface. The goal of static friction is to prevent sliding from even happening. Kinetic friction acts when the object is already sliding on the surface. The goal of kinetic friction is to make sliding quit. Understand the goal of those two. Have that committed to memory. So static friction is like preventative medicine. It prevents sliding. And kinetic friction is like curative medicine. It cures the problem of sliding. The symbol for the force of friction is F sub F. However, this does not specify which type of friction acts. The symbol for static friction is F sub Fs. Only use this symbol if you know for sure the friction type is static. Meanwhile, for kinetic friction, F sub Fk. Only use this if you know for sure it is kinetic friction. So what causes friction? Friction is caused by intermolecular bonding. Molecules in the object temporarily bond with molecules on the surface. As the molecules attract each other, they try to prevent the object from sliding on the surface. Static friction occurs when the molecules don't move past each other. This results in stronger bonds. So static friction is a stronger type of friction than kinetic friction. Kinetic friction occurs when the molecules move past each other. This results in weaker bonds because the bonds don't have as much time to form as molecules slide past. So kinetic friction will always be weaker than static friction for the same object and the same surface. All right, so if we think about this on a really small scale, let's say we have a box, and that box is on the ground. Nice flat ground. Please pretend it's flat ground. That way you don't get confused. All right, so nice flat ground. If we zoom in to this and we look at what's actually happening on the molecular level, it's going to kind of look like this. So for the surface of the box, there are these small little ridges. This is the box. And then for the surface of the ground, there are these other little ridges. And these ridges come in contact at certain points, and that's where your bonding is happening. So as long as that box is sitting right there, then you'll have these bonds happening at these random places, and the bonds are strong or not strong, depending on what's in the box. If it's a lot heavier, then you're going to have a lot more push down, and you're going to have more points of contact for these bonds to form. So the idea of these little teeth, I think, helps to understand what friction actually is and how it prevents sliding. Looking at it again, there are these little rough surfaces. And you have the same thing on your hands. So when you rub your hands back and forth together, you push down really hard and you start rubbing back and forth, then you are getting these bonds that are breaking. So some of your mechanical energy is converted into thermal energy through this process.